Okay, we're back again. Something quite rare happened at the end of the last stream, or, well, the last recording. I did some actual research. I try not to do anything off camera as part of the project, but we've been stuck on this for a little while, so I wanted to spend a little bit of off camera time just reading documentation. If we go to this examples here, encode video, this is pretty much exactly what we want. So they, as in FFmpeg, go with the encode a frame manually or create a frame manually rather than the create a, it's still a frame, I think it's a packet, rather than create a packet manually. But essentially, so this is in the codec, they set a couple of parameters, yeah, a couple of codec parameters, whatever. Yeah, and then alloc a frame, get frame buffer, a magic function which doesn't tell you anywhere you might need, oh, excuse me, which calls this function, which fills in a bunch of stuff. So this does some stuff for you. It doesn't look like it does that much, but it does fill out a bunch of, I guess, fields in the frame. And this doesn't matter so much to us right now, but it will at some point. And then they just encode the frame, which involves just sending it to the encoder and then receiving it from the encoder. So this is pretty much exactly what we were doing, which raised the obvious question, why it no work? So let's do something. Yeah, so it turns out it was just working the entire time. It seems to be the case that we'll kill this, which it might segfault. Okay. Yeah, it turns out that one Matroshka is a format which just requires more information that we weren't giving. So if we go back to FF tools, and then I guess it's this one, I think. What? Not that. I think it's ifile, or it's iopen, or if open. If open, whatever. Somewhere in here. Yeah, there's a bunch of metadata added to the container format of the output. My hypothesis is that's actually necessary for Matroshka, but it's not necessary for MP4. We messed up our, well, yeah, okay. So there are two issues here. One, we've seen this issue a couple of times before. Basically, we don't drain the codec or write the trailer for the container format correctly, as in at all. And that actually matters. So somewhere out here, we want to do something like video outputs. And then maybe we want to do like a nano sleep. I don't really care for this. Struct time spec. And then this will be, is it nano sleep? And then we'll have a rem, something like that. And then afterwards, what we need to do is we need to do like a, yeah, we'll do that, but Oh, right, because they actually just send it to the encoder. They don't. Yeah, it doesn't get written to a container. Yeah. Just gets F written. Yeah, okay. But yes, we do need to do an AP format free context, and this comes from video outputs 0.frame format. But we also need to do, it's like a write trailer. Yeah, AV write trailer. Guess it's the format context. And we need to free it, something like that. Oh, that needs to be a... Okay. Okay, and then it's just buffering all this. Okay, now it's actually encoding. Whoop. Okay, it didn't segfault, that's nice. Okay, brilliant. So the first problem was that trailer nonsense, and the second problem is obviously we're not encoding correctly. All right, so you can kind of see that this is repetitive, which seems to indicate that, well, I'm gonna talk out of my ass a little bit here, but it seems to indicate that we're not writing just like completely random data. It seems like we are encoding it incorrectly, or packing it incorrectly potentially. So one problem is we actually are doing this calculation incorrectly, the conversion from RGB to UV. Oh yeah, and also you might notice here that the creating frames is supported, and we had it working, just didn't realize. So getting rid of this is going to be up next, or rather, going back to all this stuff is going to be up next. Except we won't need all of it, but going back to this is coming up next. But yeah, it turns out the AV1 codec is just stupidly slow. So it looked like it was, it was so slow that it seemed like there was a problem. Like fundamentally there was a problem. But no, it turns out that codec's just really slow. So that would have saved quite a bit of time. Are these right? Yeah, I would hope that it does the truncation. Here we go. And so the red, green, and blue components are all yeah. Are these meant to be in a scale from 0 to 1? Should be a minus. Should be looking down here. Should be a minus. Yeah, are these meant to be 0 to 1? Because what happens if you add these? You get 80, you get 90, you get sort of 230-ish. Isn't that around the max? Yeah, around 240. So I feel like these are meant to be in a scale from 0 to 1. Right, but then you divide through by 256, so it's fine. I think. I think it's fine. I think it's fine. Let's see if that's any better. Let's, that almost looks like a image in there, but I may be just seeing things through the colors. Let's actually switch from this method to the frame method, because it's a little bit easier to know how to lay out the memory, because it's planar. So we'll do that switch now. I'm also tempted to drop the alpha channel, but I think we need it for blending of windows, because we need to blend the alphas. It's actually going to be a good question of how to... it might not be too bad. I was thinking about how to blend in the case of windows that we're not recording, but are still in the way. But I think as long as the alpha channel itself is recorded and not just the result of the blending, then it should be fine. Then we should be able to compute the true color ourselves when we get to it. Yeah, so let's get rid of all this stuff. Do we get rid of all of it? No, maybe. Yeah, let's get rid of all of it. Goodbye. We're going to get rid of that, and we will do this, get rid of those. We'll keep that comment there.